Welcome to Spring LIB.
7.73, so we're pushing a block up an incline by pushing on it horizontally. And we have some information here, and one perhaps interesting point about this problem that we've not necessarily seen a lot before is that the block is already going at 3.25 meters per second up the plane before we start pushing on it. So we want to find the initial kinetic energy, the work done by our force, gravity, and the normal force, and then what its final kinetic energy is. So the initial kinetic energy is going to be 1/2 m v1 squared, of course. So that's 32.2 joules. Now the work that our pushing force does is going to be the magnitude of that force times the distance it's being pushed times the cosine of the 37-degree angle between the horizontal direction of the force and the inclined direction of our displacement. So that's 554 joules. So for the gravitational work, it's the weight of the book times the distance it's moving. And now the angle between the downward weight of the book and its displacement is 90 plus this, so 127 degrees. So that's negative 333 joules. The normal force is perpendicular to the displacement of the block, and so the cosine of 90 degrees is 0, so the normal force doesn't do any work. And so from the work energy theorem, the total work is equal to K2 minus K1. So the final kinetic energy is going to be starting kinetic energy plus the total work that's been done. So this is our 32.2 joules plus 554 joules from pushing on it minus 333 joules from gravity resisting sort of that increase in height. And so the final kinetic energy is 253 joules.